This short video is done on an iPhone, so the aspect ratios may be off just a little bit, but I'm going to illustrate the process that I went through to refurbish this little steam engine. As you can see, it was heating up there in that previous video clip. This is a Watt Victor steam engine. It's a 250 watt electric, and the boiler is heated from a heating element. And as you can see, I'm measuring the temperature of the boiler right now. The base, when it's running at full speed, the base will run around 300 degrees. And then of course the rest of the boiler temperatures drop as you get closer to the top. But the steam running around 220 degrees roughly as it comes out of the valve body there. With a little bit of encouragement, we'll get this steam engine to begin to spin up. And we experimented with different kinds of oils and cleaning on the valve body and the connecting rod and the crankshaft. There were a number of issues, all compounding the problem with it not running very fast. And of course, as we know, faster is better, right? So it's a reflection of the efficiency of all of the components working together to allow the engine to run fast. So as the temperatures rise here, we'll get the engine running here in just a moment. Now you can see the engine is running and the temperatures are running around 190 degrees at the valve body, somewhere in that range, 190 to 200. We're going to do an RPM test here in just a moment to let you see the speed of the steam engine. Now keep in mind, my RPM meter will only go down to 500 RPM. So what we're going to do is we're going to look at the mounting screw on the end of the flywheel, the tip of the flywheel, and when we see two mounting screws, we can cut the RPMs in half. So we'll run the RPM meter up above 500 somewhere, and we'll see if we can get it, or some multiple of 500, and we'll see if we can get a reading on the speed of the motor. Alright, we're looking through the shutter of the RPM gauge, and you can see the mounting screw rotating. What we're going to do is try to get that mounting screw to stop, and then we'll make a judgment on the speed of the flywheel.
$550, $580. So it's still going too slow to pick it up. So what are like?
So there you can see the RPM gauge is reading 852, and we have two screws, so we'll divide that by 2 to about 420, 526 RPM. Now here is a shot using the infrared cam, and then we quickly jump to a photograph of the repairs that I did to the bottom of the boiler. I used epoxy putty and then spray paint with high temperature paint to seal the base of the boiler. Then I added oil to the cylinder, and this is an actual RPM reading. You'll see a single screw in the window there. It's very difficult to see, but the actual speed of the flywheel now is a full 900, and by the time I finished with this test, I got it to 950 RPM, which is about double the speed. About 30 seconds ago, I unplugged the boiler, and we're going to just let it set here and run without any electric heater running, and we'll see how long it runs. In the past,
got up to 950.
When we were getting about 300 to 400 RPM on the flywheel, when we would unplug the power, the unit would run for about 10 to 15, maybe 30 seconds at the max. In reality, after repairing and oiling the motor, we now are getting about 2 minutes and 30 seconds of runtime without the power, which is pretty impressive.
And this is running without any electrical.
Is a red 3D printed flywheel that we were experimenting with, trying different flywheels. We're going to try to double the size of the flywheel and find one that's actually not out of round and see how we can do on our RPM tests.
It's still running.
So to summarize what we did, we've balanced the flywheel, and you can still see there clearly that it's out of round, which is creating a problem for its speed. I would imagine you could get 1200 RPM if you had a perfectly balanced flywheel. But the oiling of the cylinder chamber and the valve body, connecting rod, and crank shaft, all of those together make a major difference in the ability of the steam engine to run and run smoothly. And you can see how smoothly it's running here, even at the very end of what's left of its steam in the boiler.